I just found this application problem from the internet. It is said that it is one of the hardest problems of the university entry exam of Scotland of some year. And the usually high-achieving students only achieve a passing grade from this just because of this problem. So here, so that's a little bit background of this problem. And so here's the river bank. The river length is 20 meters, and the width of the river is 6 meters. And the crocodile travels at different speed in the river than compared on the land. So it's only 0.2 meters per second in the river. And so it's 0.25 meters on the land just to chase the zebra. And we can just treat the zebra and the crocodile as points. Right? Here is a moving point. There is a fixed point right here. And of course, we're looking at how long should what kind of path, right, should the crocodile choose? Right? In other words, we must determine how long does it have to travel in the river, right, before it reaches the land, then complete the rest of the course just at this speed. Right? We can set this length as x. And of course, the width is 6 meters. Right? Then we can calculate the hypotenuse. Hypotenuse is just square root of x squared plus 36. Right? Then we divide it by the speed, calculate the time taken during this course. And then we will calculate this length, this distance. Right? This distance is just 20 minus x. And divided by the speed on the land, right? We divide this by the speed in the river. So the total time function in terms of x, I can express it as square root of x squared plus 36 divided by the speed in the river, 0.2 plus 20 minus x divided by the speed on the land, 0.25. Okay. That is just 5 times square root of x squared plus 36 plus 4 times 20 minus x. Okay. Several different methods. First method, I'm going to use calculus. And so derive the derivative. I'm going to use the chain rule, of course. 5 constant, half, and the square root of x squared plus 36. Chain rule, 2x. Then minus 4. We can let this equal to 0 and see what happens. If that's equal to 0, then we have 5x over square root of x squared plus 36 equals 4. Right? Then we say 16 times x squared plus 36 is equal to 25x squared. Rearranging everything. 9x squared is equal to 16 times 36. Right, so 9 is gone. Here I have 4. Right, so that is just 64. So x in this case has to be 8. Right? Of course, has to be positive. Right? It's time, 8 seconds. 8 meters. Right, from here to here, 8 meters. The remaining is just 12 meters. Now, since this is only the solution of the first order derivative, right? I'm going to also have to calculate second order derivative to test if this is the minimum or maximum. Right? T double prime. Double prime, that is equal to x squared plus 36 5x times square root of x squared plus 36 minus, no, 5 times square root of, then minus 5x derivative of that is half of square root of x squared plus 36 times 2x, chain rule. Right? 2 and 2 gone. And this becomes 0. That is equal to common denominator, right? Then combined with this, x squared plus 36 to the power of 3 over 2. And I have 5 times x squared plus 36 minus 5x squared. Right? That is equal to 180 over x squared plus 36 to the power of 3 over 2. Right? So no matter what happens, this is going to always be positive. Right? So that means really it reaches minimum. Right? Second order derivative always positive. Right? So really minimum happens when x equals 8. Right? That's the minimum of time taken. So in that case, t of 8 is equal to 8, 64, 100 squared, that square root 10. That's 50 plus 12 minus 8, 20 minus 8, 12 times 4, 48. 98 seconds. Right? Really, that's the minimum time taken. Because otherwise, if we can test, if we can travel all the way to here, then we complete the remaining course, right? What will happen? And then we can say, right, this distance, 6 meter divided by the speed in the river, 0.2 plus the remaining course, the whole 20 meter divided by the 0.25. Right, that is 6 times 5, 30. 4 times 20, 80, 100, 110 seconds, of course. That way it's longer than 98 seconds. Right? Otherwise, if we travel from this point all the way to this point, right, the whole course is taken in the river. Right? We travel 0 meter on the land. So what's going to happen? What's going to happen is this hypotenuse, right? This point to this point, hypotenuse, 400 plus 30. So 400 plus 36 square root, right? Divided by the speed in the river, 0.2, right? That is approximately, so the time taken to travel only in the river, right? 0 meters on the land, it'll take us approximately 104.4 seconds, right? Both of them are longer than the 98 seconds, right? If we chose to travel 8 meters, right, across, right, meaning we travel hypotenuse in the river of just square root of 64 plus 36, square root of 100, that is 10 meters, right, in the river, and then complete the remaining of the course, that's 12 meters on the land, right? That's the most efficient course in terms of the time consumed. Right, the second method, I'm going to use draw this line. I'm going to draw this line and make sure that I'll explain why. So I'm going to make sure that this angle, let's call it alpha. Right? I'll make sure that the sine alpha is exactly 4 over 5. I'll explain why. In other words, tangent alpha I'll make sure it's 4 over 3, right? This is obvious. 25 minus 16, 9, square root of 9, 3. So that means if I can perhaps draw this line and meet with this line and make sure this is perpendicular. So that way, like I said, sine alpha 4 over 5, right? That is this segment over this segment. I'll make sure it's 4 over 5. Why is that? Because the speed in the river is 0.2, right? Right, that's in the river. And on land, it's 0.25. 1 over 5. Right? So the speed, in terms of the speed, the ratio of land and river, right? On the land, it's quicker, right? So 1 over 4 divided by 1 over 5. Five over 4, right? A little bit quicker than the river. So that's why I make sure that this segment over this segment ratio is exactly 4 over 5, right? So in that way, since if I set the speed of from this point to this point, if I set the speed exactly the same in the river, right? 0.2, that means this speed over this speed is 4 over 5, right? Also the distance, right, is also 4 over 5. In other words, the moment I reach to this point, compared with the moment I reach this point, they should take exactly the same time, right? Because like I said, the ratio between the distance and the ratio between the speed is exactly the same. Therefore, time taken will be exactly the same. Therefore, in order for me to calculate the time taken from this point to this point, all I need to do is to calculate the time taken from this point to this point, right? As long as I set the speed during this course, the same speed in the river, right? That's all I need to do. Right? So in other words, the speed along this course will be exactly the same speed from this course, in the river, right? So all across the point, from this point to this point to this point, I have exactly the same speed, right? Then how do I calculate the shortest time? All I need to do is to calculate the shortest distance from this point up to this point. What is the shortest distance? Straight line. It's neither this than this, neither this than that. It's exactly the straight line from this point to this, because this line is already fixed, because this angle is already fixed. All I need to do is to draw straight line from this point up to this point, intersecting with this line, right? That's where the minimum time will occur. Right? So in other words, this angle is equal to this angle. Right? This angle is equal to this angle, 90 degrees. In other words, alpha, this angle is equal to this angle. Right? So this angle, again, this line and this line are parallel. So this angle is also alpha, right? Like I said, I make sure tangent alpha is 4 over 3. Right? Tangent alpha is this over that, x over 6. That's what I made sure. So in other words, x is equal to 8. Right? That's when the minimum time will happen. Right? Exactly the same result as we derived earlier using calculus. Right? So Here's the third method. Right, third method. Because previously, I remember I set the equation to be 5 times square root of x squared plus 36 plus 4 times 20 minus x. That's the time, right, in terms of x, if I remember correctly. So this time I'm going to use Cauchy inequality. Right, Cauchy inequality tells us that a1 squared plus a2 squared times b1 squared plus b2 squared. Right, if we only have 2 pairs of numbers, right? Usually we have n pairs. Take the square root is bigger than or equal to the a1, a2 plus a1, b1 plus a2, b2. Okay? So a1, b1 plus a2, b2. Right? There's no square because I've already taken the square root on this side. So let's determine which one is a1, which one is b1. Right? How can I make sure that after I apply this Cauchy inequality, I can cancel out the negative 4x? Right? That's my purpose. How can I cancel that? So in other words, 5 times square root of x squared plus 36. How can I rewrite it? How can I? So can I say that x is a1 and 6 is a2? Can I write that? So x squared plus 6 squared. Right? Then what is b1, b2? Right? b1 squared, b2 squared. Perhaps I can rewrite 5. Most importantly, a1, b1, I'm hoping to cancel out the negative 4x. Because in the end, I want to reach constant instead of x, right? 'Cause otherwise it will be pointless. So that's my purpose. So if I take x, because remember in the end, I'm going to have a1, b1, right? a1, b1, right? a1 is x. So which means maybe b1 should be 4, because then I can have 4 times x, cancel out this negative 4x, right? Maybe that should be the case. So maybe that should be equal to, rewrite 5 into, I'm going to take the square root. So first of all, x squared plus 6 squared. 5 maybe can be written into 4 squared. There's a square root outside here. So that way I can say, it says a1, b1, a1, b1, a1x, b1, 4, a1, b1, 4x, cancel out negative 4x, right? So I'm almost halfway through. So square root of 4 squared plus what squared gives me 5? 5 is in fact square root of 25. So 25 minus 16, 9. 9 square root 3. 3 squared. Indeed, 16 plus 9, 25. 25 takes square root 5. Exactly. So then Cauchy inequality. Yeah? So a1, b1, a1, b1, 4x plus a2, b2, a2, b2, a2, b2, 6 times 3, 18. Right, there is no square right here. And so this is greater than or equal to that. So replace this with this, right? And also here I have 80 minus 4x. Right, so minus 4x plus 4x cancelled out. 80 plus 18. 98, right? So when does equal sign happen? It happens when the Cauchy inequality tells us equal sign happens if and only if the pairs of numbers have exactly the same ratio. So in other words, happens only when A1 is equal to lambda times B1. A2 is equal to the same lambda times B2, so on and so forth, right? So AN is equal to lambda times BN. But since we only have two pairs of numbers, so then this is already enough. Now it says A1 is X equal lambda times B1. B1 is 4. Right? Also A2 is 6. Right? 6 equal same lambda times B2. B2, like I said, B2 is 3. Right? So lambda is equal 2. So X is equal to 2 times 4, 8. The same result.